Okay, we are on to some more very cool properties of exponents in this section 11.2. I can understand and simplify expressions with zero and negative exponents. All right, so again, some awesome properties. These are going to be really cool once you get used to these. So the warm-up says, in the expression negative 3x to the fifth, what is the base, what is the coefficient, and what is the exponent? Now, please notice that this comes in a different order. This says what's the base, what's the coefficient, and what's the exponent. So be careful here. If we want to find out what the base is what's underneath that exponent. It's the only thing the exponent applies to. So notice the exponent right here is 5. I'm going to go ahead and write that. The base then is what it's over. This is not in parentheses, so the base is just the x. The negative 3 is not included as part of that base. So x is the base. The coefficient, there's only a negative 3 out in front there, so the coefficient is negative 3. We'll go through on these next couple and we'll just simplify these using the rule that we learned yesterday. So if I have 10 5s being multiplied together here and another 12 5s being multiplied together there, again the rule says if the bases are the same, then we add the exponents. So you could do that work, or you could just write down this would be 5 to the 22nd because we've got 22 5s that are multiplied together. So you could just leave it at that. On this problem right here, again, we're going to look at the coefficients first. So negative 3 times 4 is going to be negative 12. And then we run through and we think about how many x's do we have here? Well, we've got 5 x's here and we've got 2 x's here. They're all in a big multiplication problem, so that means 7 of those are going to be multiplied together. Take a look at this. We've got 3 negatives, so the answer is going to be negative. If we go through, this would be a negative 1 times 2. Let's see, so negative 1 times negative 2, positive 2, and then we multiply by negative 5, so this is going to be negative 10 altogether. If you wanted to, we could just say, okay, the answer is negative. 1 times 2 is 2, 2 times 5 is 10. And then again, we're going to put these in alphabetical order, so let's check and see here. I'm going to do the x's first. So this is going to be x to the third, x to the fifth. There's 3 x's there and 5 more there, so that's going to be x to the eighth. And then let's go through and let's take a look at the y's. I've got y to the fourth and y to the third. If there are 4 y's here and 3 y's there, that's going to be y to the seventh altogether there. So I'll go ahead and circle that. Now, we have only dealt with positive exponents so far. It is actually possible for exponents to be 0 or even negative, and that's the goal of what we're going to do today. Is we're going to figure out how do we deal with 0 or negative exponents. Now in future classes, you're even going to run into exponents that are fractions, and those are crazy wild. They're really pretty cool. Right now we're just going to look at some examples and try and figure out how 0 works for an exponent and how negatives work for exponents. So in this example, it says for part A, it says write each of the following in expanded form. Now we've done that before, so we're just going to write 2 times 2 times 2. So repeated multiplication. We're going to multiply by 2 3 times. So 2 squared is 2 times 2. And 2 to the first means there's only one 2, so I'm going to write a 2 there. Now we're getting to the point where we're going to figure out what 2 to the 0 power is, but I've got a couple questions for you. First of all, what number can be part of any multiplication problem without changing the answer? Well, 1 is what we call the multiplicative identity. So if we multiply each of these problems by a 1, so I'm going to put a 1 here, put a 1 here, put a 1 here. Basically what this is saying is start with 1 and multiply by 2 3 times. Start with 1 and multiply by 2 twice. Start with 1 and multiply by 2 once. Well, if this pattern follows here, the only thing that's going to change is we don't have any 2's, so the answer to this one is 1. Now again, just as a reminder, a positive exponent, as we've got here, is shown as repeated multiplication. It's shown as repeated multiplication. All right? Now, if we come down to this next part, if we've got the positives covered and we've got the 0 covered, and we'll summarize this again in just a second, the word negative usually means opposite. Okay, so let's talk about what that might mean in this situation. A negative exponent is shown as repeated, okay, not multiplication, but as repeated division. So what this means is we're not going to be multiplying by 2 once, we're going to be dividing by 2 once. So we're going to divide by 2. Now notice that the 1 is still there. The 1 is always part of that problem. So on this one we're going to divide by 2 twice, so 2 times 2. And on this one we're going to divide by 2 3 times, so that's going to be 2 times 2 times 2. So if we were to simplify this, this would be 1 over 2 to the first. This is 1 over 2 to the second, and this is 1 over 2 to the third. Okay? So we get the same type of thing here. This is repeated multiplication, and we've got this pattern of doing something repeatedly. And when we have a negative in the exponent, it means we're going to repeatedly divide. What happens is it ends up in the denominator. So this exponent, the part of this exponent that changes this, is the negative. The negative means it's going to end up in the denominator, and we're going to have a word for that in just a second. I do want to do one more thing. This would be 8. This would be 4. This would be 2, and this would be 1. Now take a look at what we get here. This would be 1/2. This would be 2 squared is 4, so that would be 1/4, and this would be 1/8. So look at this nice pattern here. We have 8, 4, 2, 1, and then we have a half, a fourth, an eighth, and so forth. So let's try and summarize this so we're clear on how this works. And this is something that you need to have memorized. These do tend to give people trouble when they run into zero exponent or a negative for an exponent. But if you've got this memorized, this hopefully will clear things up. So when we see a negative in the exponent, that negative means this word right here. It means reciprocal. So the reciprocal of multiplying is dividing. So reciprocal, spell that right. So here's what we've got. If we have b to the negative n, then we would put a 1 on the top and we would put the b to the n on the bottom. That negative moves it from the top to the bottom. And remember, there's always a 1 as part of any multiplication or division problem. That's not going to change the answer at all. And then this one, people forget this all the time. They think, oh, if there's a 0 in it, the answer's got to be 0. But remember, you've got to realize that these are multiplication problems, and 1 is always part of a multiplication problem. So any number to the 0 power is 1. So b to the 0 is exactly 1. So I'm going to slide this down and we're going to take a look at a couple of these. So again, I'm going to star this because you've got to have this figured out. This is really the best way to remember these two things. Any number to the 0 power is 1 because 1 is part of any multiplication or division problem. And a negative in the exponent means reciprocal. So that means we're going to go from the top. We're going to put that same exponential expression in the denominator. Now, you might be confused right now. You might think, oh my gosh, how's this going to work? It's really very quick and very cool, especially if you've got this memorized. So we've got 5 raised to the 0 power. This is as awesome when you learned about multiplying by 0. 5 billion times 0, you know, little kids go home and tell their parents, hey, what's 5 billion times 0? And they say the answer is 0, and they just think that's cool. Well, check this out. 5 to the 0 power is 1. Done. End of story. That's it. Any number to the 0 power is 1. So if we take a look at this one right here, x to the 0 power, we may not know what x is, but we know it's a number, so any number to the 0 power is 1. So we're going to circle that. Now we take a look at this next one, and this is really important. It's got an asterisk by it. I'm going to put a star by this. This is something that people forget all the time. I guarantee somebody's going to forget this on the test or quiz from this unit. It says, remember, the coefficient is not part of the base unless it's in parentheses. So you'll notice that the 7 is not in parentheses with the y. So what we've got here is we have 7 times y to the 0 power. These are stuck together. This is an exponential expression. So the 7 is just sitting out in front. What is y to the 0? Any number to the 0 power is 1. So the answer on this one is 7 times 1, which is just plain old 7. Okay, so that's how we work with 0 for an exponent. Let's come down here and take a look at some negative exponents. This is 5 to the negative 2. So again, the best way to think of this is the negative part right here means reciprocal. So we're going to take this and we're going to move it on to the bottom. So this is going to be 5 squared on the bottom. Again, there's a 1 left of any multiplication problem. So there's the answer right there. All we do is we move this into the denominator and we change the sign from a negative 2 to a positive 2, and that's it. So if we take a look at the next one, this would be 1 over x to the third. Literally that quickly. So on this one right here, again, take note, it's got a coefficient. It's not in parentheses. So the 7 is just fine. Technically, the exponent on the 7 is a positive 1. So we like that. We're going to leave that up in the numerator. There's nothing wrong with that 7. The y to the negative 4, the negative in the exponent means reciprocal. So we're going to write that on the bottom. So we have 7 over y to the 4th, and we are done. Now, if you wanted to, you could change this and you could say, look, I've got a 7 times. This would be 1 over y to the 4th. Go ahead and think of everything as a fraction. You still get the same answer. So either way you want to think of it is totally fine. And then let's take a look at this last one. This is a cool one. This is g. It says 7y to the 0. Now that's very similar to this one right here, but there were no parentheses on this one. We put them around the the y to the 0 power just to kind of emphasize that the 7 up here was the coefficient. The 7 here is in parentheses, and we're raising the whole thing to the 0 power. So 7y is the base. So whatever this number is, I'll put a big blob right there, whatever that number is, it's raised to the 0 power. So the answer on this one is 1. End of story. That's it. So anytime we have a number or a variable raised to the 0 power, it is 1. Make sure you're careful with whether or not the parentheses are included or not, and that determines whether or not the coefficient is included or not in the base. So let's come down here, and I think this is the easiest way to do these types of problems. It does say that our answer should contain only positive exponents. So if we go through here and think, hey, we really don't like negative exponents, so we're going to use the idea that it's the reciprocal. Notice that the -2 is a coefficient. It is not underneath the -6, so it does not have a negative exponent. In fact, if we wrote it, it would just be a 1. So the -2 is totally okay. We're going to write that y to the 6th on the bottom because, again, the negative means reciprocal. Okay, so there's our answer right there. Done. End of story. Take a look at the next one. We've got a 7, m to the 0, so that would just be a 1. Okay, and then we've got n to the -8. No problem with the 7. 7 times 1 is just 7. So I'm going to leave the 7 on the top. But again, the negative means reciprocal. So this is going to be n to the 8th on the bottom. Circle that and we are finished. Next one, we've got some coefficients. Let's take care of those. So those multiplied to be -8. This is x to the -5. The -5 means reciprocal, so we're going to move that into the denominator. So that's going to be x to the 5th down here. We don't like negative exponents on this, so we're going to take advantage of that, and we're going to say, look, that just means reciprocal, so that would be y to the 8th down there, and we're done. Notice that the things that had positive exponents are still in the numerator, and the things that had negative exponents, they now are in the denominator. They're in the bottom. So let's take a look at part D. We've got -9 w to the 0. Remember, that's just a 1. And then we've got w to the 2nd x to the -3. So there's nothing wrong with the -9. We're going to leave that on the top. There's nothing wrong with the w squared. That's got a positive exponent. But this has a negative exponent, so the negative means reciprocal. So we write that on the bottom. Finished. Okay, let's keep moving. Same idea here. I like to go through and think, okay, can we simplify anything? And on this one, we've just got 4 different variables here. And think anything with a positive exponent, totally fine. We're going to leave it where it is. Anything with a negative exponent, that negative means reciprocal, so we're going to move it into the denominator. So the 7 is totally okay, and the x squared is okay. Those both have positive exponents, so we're done with those. Each one of these has a negative exponent, so let's go ahead and move those in the denominator. The negative in the exponent means reciprocal, so this would be w to the 5th. The negative in the exponent means reciprocal, so this would be y. I'm just going to write to the 1st power, or think of it to the 1st power. And then the negative in the exponent means reciprocal, so this is z to the 6th. Again, everything that was negative, those 3 variable expressions right there, they end up in the denominator because their exponents were negative. The 7 and the x squared end up on the top because their exponents were positive. Okay, last one. Take a look at this. We've got a 3 to the -1, a to the -2, b to the -3, and c to the -4. So let's take a look. Remember, we said anything with a negative exponent, we've got to use that reciprocal idea. So the reciprocal here would be 3. I could put to the 1st power, but I'm just going to put 3. A to the 2nd would be on the bottom, B to the 3rd would be on the bottom, and C to the 4th would be on the bottom. And then we've basically moved everything. So then the question is, what goes on the top? Well, remember, 1 is part of any repeated multiplication problem, part of any repeated division problem, part of any multiplication or division problem, period. It doesn't change the answer. And we've got to have the 1 up there so everybody knows that these aren't still in the numerator. Okay? That's how you do the problems. Good luck on the assignment.